All right, guys. Very good morning. Welcome back again. Again, this is going to be one of the continuation for my yesterday's demo class, right? On Oracle RAC administration workshop. So, before I continue with this today's scheduled demo topics, I would like to take any questions or queries if anybody has it based upon our yesterday's session. If not, then I can continue with this today's demo session. I am planning to cover 3-4 topics for today, and then we can wind up this demo classes. And then in between, if you have any queries, questions while explanation, you can stop me, or you can raise your hand, and then or you can post your queries in the chat box. Right. So just to recap, we covered yesterday about the course curriculum and the course timing, and then the course duration, and then the course fee structure, and also about the how this particular course is formed and what are the advantages of taking this course, and about the recorded sessions, about the course materials, and about the ready VMs, and about the WhatsApp group and the support. All those will be provided once you register with this course. That's all we covered, and followed by we started understanding a little bit about RAC architecture and some of the networking concept in RAC. So that's all what we covered in our yesterday's session. So today we will again understand a few more things inside my Clusterware, and then followed by my Clusterware startup sequence and my Clusterware basic administration. These are the 3 topics we'll try to explore today on this demonstration. Uh, let's get started then. If don't have any queries from anyone, so let's get started. First thing is, I will try to explain this particular slide here. This is what we covered yesterday. Standalone versus RAC. Standalone is one-to-one mapping. RAC is many instance mapped to one database. So that is like one-to-many mapping in case of RAC. So in case of any one instance goes down, you have other instance to survive incoming connection, or whatever the connection connected to node 1. If that node 1 goes down, automatically that connection will go to any of the other surviving nodes. So that's called failover. That's kind of one of the high availability can be achieved if you are using a RAC. In case of standalone, if one instance goes down, everything will be down. You cannot access your database. So at a high level overview, whatever I explained here in the RAC high availability, so that can be we can visualize in this pattern here. So client will connect via public network. So that public network using a scan IP, he will be connect to any one of the cluster node using that node VIP. From the node VIP, so he will be able to access that particular. Once he connect to the node VIP, from the node and to the storage, or from the node to other cluster nodes, all the communication will happen via the private interconnect. So we talked about that private IP addresses, right? So all the node communication or the disk communication will happen via that private IP addresses or the private network. So those are the 2 minimum networking needed here. 2 separate subnets are needed. One is a public subnet, one is a private subnet. Private subnet for the inter-node communication and to the storage communication. So the public one will be for your scan, and for your node VIPs will be and also your node IPs. All 3 will be in our public subnet or public network, and your private network will be internal for the node communication. So this is a high level what you can visualize how the RAC setup looks. So apart from this, I would like to explain this particular slide here. As we know that our database will resides inside my ASM disk groups, uh, my data disk group, record disk group, FRA disk group, redo disk group, whatever the disk group what you created inside your ASM level. So inside that disk group, you're gonna place your database. Place your database in the sense you're gonna keep all your data files, all your control files, all your archive logs, redo logs, and all your whatever like related to data file. Everything you're gonna keep it inside your data disk groups or the ASM disk groups. And in order to access that particular database, all the end users who are connects from mobile or URL or internet or desktop, whatever the mode they will connect, all the connection will go to your application server. From the application server, it will connect to your node VIP. From the node VIP, it will gonna connect to your uh, database. So when your application team is configuring your app server, whatever it is, whether it's a EBS, OBI, PeopleSoft, or your Tomcat, Apache, whatever it is, when they're trying to configure their application, we are going to provide something called TNS entries. So that TNS entry should be your scan entries. So if I go here, so this is my, I'm just going to give scan name here, right? So I'm just going to give, I'll just make it as a DevDB. This is my database. I'm just going to give this particular DevDB uh, TNS details to my application team. They will configure this particular TNS details inside their application. So whatever that end users is going to connect to my database, he's going to use this particular scan name here. And then we know this particular scan is like, I'll just put it down. I have node 1 and let's put it here. I have node 1 and then I can put 192. I'll just take this particular IP. Node 1 has this IP and then 101, and then this is my node 2. Node 2 has 102 IP, and then node 1 has its node 1 VIP. I'll just want to take my node 1 VIP here. And I'm just going to take it for 2 node as an example. Right, so this is node 2 VIP. 1, 2, and then this is 3, and this is 4. So these are my node 1 VIP, node 2 VIP. Those are like public. And then my scan will be in the same public subnet. I'm just going to put that scan IP here, 105, 106, and 107. So 1, 2, 3, 4, 5, 6, 7. These are my public network which are in 1.series. So which are in a public subnet. And then this node 1 and node 2 will be having its private IP. So I'm just going to make it as a node private IP. So that will be in the different subnet, right? So I'll make it as a 2. So this is my node 1 private IP, and then this is my node 2 private IP. Right. So there are 2 concepts. One is why scan and why VIP. We have a node IP, and then why we need a VIP, first question. And then once we have a VIP, and then why we need scan IP. That's the second question. Let's assume here, whatever I explained here, I can put it in a MS Paint here. Okay, let's take this as example. I'll take node 1 and node 2. Right. When my end user is configuring my application, right? And then I need to give node IP. I have this node 1 IP here. And then I can just Here. Node 1 IP I can give this one, and node 2 IP I can give this one. So when they're configuring their application, I need to give TNS details. And assuming that my dev database is running here. Let's go here. So assuming that my I can say dev db1 is running here, and then dev db2 is running here. So underlining my storage will be ASM disk groups, and this is my entire disk group, ASM disk group, and these two database instances will be residing inside my disk group here, right? When your application team is trying to connect application for this dev database, and you need to provide TNS details. So you're going to provide TNS details something like this. We're going to give something like this. I can just put it here. Right. So instead of scan here, I'll give something like this. I'll just put it down here. Right. So I can make it here node 1, or like I can put this particular IP, the node IP. That's a physical IP. Remember, this is a physical IP, node 1, and then this is node 2. So I can give this particular TNS details to my application team, and something you can mention here, load balance equal to yes. They have earlier days, they have this concept. I just put it here. Something load underscore balanced equal to yes. Something they will mention here. I'll make it simple here. Right. So sorry for that, guys. Okay. I'll just make this one entry and then second entry. And then I'll just take this IP here. Node 1 and node 2. Right. So they will, if you give this particular TNS details to your application team or the end users, and then they will mention something like load underscore balanced equal to yes. If you give this particular TNS details to your application team, obviously they will connect to your database. It will allow you to connect to your database. But what happens? What's the disadvantages here? These are your node 1 and node 2 physical IPs. And assuming that you have some end users connected to node 1 using this particular IP. And since this is a physical IP, and if this particular node goes down and this particular client C1 connection will not be able to fail over to this node 2, because your physical IP is bonded to your interface or the NIC card. And the moment that node goes down, your IP will go down. The moment your IP goes down, the connection will be like broken. This particular end user connection will be broken. You'll not be able to fail over to the other cluster nodes. So because of that, you should not be advisable to use your node physical IP, because you will not be able to fail over the client connection in case of this particular node goes down, right? So that's a disadvantages of using your node IP in your listener or in your TNS connection. So because of that, to achieve that failover connection, so Oracle has came up with this VIP concept. So instead of this node IPs, use this node VIPs 1.3 and 1.4. I can make it 1.3 and then I can make it 1.4. So load balance equal to S. So if you use this VIP, what happens? Assuming that this particular client again connected to node 1, because that's the first entry, it will connect to node 1 using that VIP. If this particular connections or this particular node goes down, and automatically the physical IP will be not available. The moment physical IP is not available, your VIP will not go down because VIP will not be bonded to any of the interface. Those will be VLAN or pegged to any one of the interface. If the interface goes down, that particular VIP of node 1 will be floating inside your cluster, and automatically that will be shifted to any one of the surviving node. So this particular node 1 VIP will shift over to your node 2 VIP, node 2 here, node 1 underscore VIP. The VIP of node 1 will shift to node 2. And the moment the node VIP is shifted to other cluster node, automatically this client connection will be failed over to any of the other cluster nodes, right? So because of that, Oracle has came up with this particular VIP concept, right? So using this your VIP IP address, you will be able to fail over the client connection in case of node goes down or node is not available or node is crashed. So that's the advantages or beauty of VIPs. VIPs will never go down. The moment any of the node goes down, the physical IP will go down, but whatever the VIP associated to that node will be like floating, will be like hanging inside your cluster. Automatically that will be failed over to any one of the cluster nodes. You have 4 node cluster, the VIP will go to any one of that node, not necessarily second node or third node or fourth node. Any one of that node, it will go. Because of the failover ability, Oracle has came up with this particular VIP concept, right? I hope you understood about why we need a VIP than the physical IP. Even though we have a physical IP, why we came up with that VIP concept in order to get the ability to failover. Right. Any questions here, guys? Now I'm
hello,
gonna.
Sir.
Yep.
Yeah, one quick question. So after the failover, it seems to be that the node 2 is holding the VIP of its own and the failed node VIP, right?
Right.
So it will be like, it seems to be like all the connections will go to this single node at this moment.
Right. Right. That's
Okay.
correct.
Okay. Okay. So whatever connections should be going to node 1, all will be going to node 2, as well as node
That
2
is not
having.
how. That's not how it works. Like whatever the existing connection of node 1 will be automatically failed over to node 2, but the new connection will never go to node 1 because node 1 is down. Your cluster is aware of node 1. Whatever the new incoming connection comes, automatically it will route it to node 2 directly. It will never go to node 1.
Yeah, so that is like so node 2 will be having its own connection, like and node 1's failed connection will be also going to that
Right,
node 2.
right. Only that failed one. Like if already 10 connections exist, all those
Mhm.
10 connections will be switched over to node 2. But if the 11th connection is coming, that never go to node 1. Directly it will go to node 2 because
Node
your
2.
cluster is your scan will be aware, your cluster will be aware of that. Node 1 will never be available. Why should I route the connection to node 1? Directly I'll route the connection to node 2. That's cluster intelligent. So it will
Okay.
never go to node 1. The new connection I'm talking about.
So I believe that it's kind again, like it might be a high level, but my resources have to be like tuned in that way that it should work with. I mean, a single node should be configured with that much amount of resources so that it can work with both the loads of node 1
Yeah,
and node.
that's correct. Like when the node goes down, customer eventually face that high load or the
Right.
performance issue
Right.
on that particular node 1. Obviously, like huge connections will start coming into node 1. You have to figure it out what's the root cause and you have to fix that why node went down. Right?
Malik sir, one quick question here. You mentioned the session of connections of node 1 will failed over to node 2.
Right.
If you can throw some light how it will be, because I can understand VIP can be started.
No, there is something called a TAF, transparent application failover. We can configure that, and all the connections will be failed over, so that we can be covered as part of actual course.
Okay.
That needs some advanced understanding. That needs some configuration. We can cover that.
And it is part of this course, sir.
Right. That's correct.
Okay.
Right. So that's what
sir,
will.
I had one question.
Yeah.
Yeah. If I forgot to configure the TAF entry in the TNS description, so it is able to relocate the existing connection to another node.
Ideally, no. You will not. It will not be able to relocate your connections.
Okay.
Yeah, you have to configure your TAF.
Okay. If I configure the TAF, like based on thing, it will configure that existing select. If I running a select query, so if I configure the TAF policy, based on the TAF policy, it will relocate the select to another node, right?
Right. That's correct.
Okay, sir. Okay, sir. Thank you.
Sir, yeah, one more question. I might be wrong. Please correct me. So, like if I have multiple nodes in a rack cluster, so is it always necessary that I should able to, like, with SSH connectivity, I need to always I can always reconnect to from one node to another node? Is it always mandatory?
That passwordless SSH connection is mandatory for your rack installation. If you don't have a passwordless connection, your rack installation will never proceed further. So that's one of the prerequisites. You will always set up a passwordless connection. Once you set up, it's done. Like, you can use it passwordless connection to any of the node.
Okay. In that case, like from a particular node, I can switch to another node, right? In a particular session, in a single session.
So you can do from node to SSH node 1.
Right.
So it will automatically go to node 1. So from node 1, you can do to node 2.
If it's not working, then it might be a problem, right?
Only for the installation, it's a problem. Once the installation done, you can remove your passwordless connection. Not an issue.
Okay.
Only for installation is a mandatory pre-check.
Yeah, Malik, one more doubt actually from that node 1. If node 1 fails, so that VAP will hand over the connection to second node VAP, and second node VAP will take care of that one, right? That you are going to say.
Right.
So, okay. So all the connections will handle by the VAP, second node VAP, correct?
Not the second node VIP. Once that, for example, 10 connections are connected to node 1 VIP via, and then, so see, ideally this VIPs will play a role only for the connection time. Once the connection is established, so we no need of any more that VIPs. Once the connection is established, done. Like, we don't need to whether that VIP goes down or up, doesn't matter. It's kind of your listener. Listener will like handle that incoming connection, and when the connection is established, done. So that VIP not necessarily should be up or down.
Okay. So whatever that whatever the role, then the second node VIP will take care of that. That I understand, right?
Right.
Yeah. Okay.
Right.
So actually, sorry to interrupt. That VIP is automatically swapped into next node, right? It will not hand over to second node VIP. It automatically
not a handover. Like it will automatically switch to any of the cluster nodes, and then.
Okay, so we can identify that first node VIP in the second node environment, right? We can check.
Right. Yeah. I showed you, right? Yesterday I showed you. I brought it down node 1. Automatically that VIPs are switched to node 2.
Node 2. Okay, then fine.
Yeah. Again, I'll show you after this one.
Sir, which process actually brings up the VIP in a surviving node, and how does it check that node has failed?
Yeah, we'll cover that advanced internal concept, which service, which processes, and which log you can check it out at high level. Right now, what you need to understand is how it works. But if you talk about the background processes and troubleshooting, right, it will take a lot of time and a lot of confusion for many of folks. Yeah. Right. So that's about your physical IP versus VIP. So that's how VIP came. I think starting with your 11G release 1 onwards, 11G release 1 or release 2, I'm not sure. I can check my deck. I can confirm on that. But it's 11G release 1 or release 2. This VIP concept came here. And now it's all absolutely works fine with VIP. I'm able to do a failover. I'm able to do a load balance, and everything works fine. But why we need a scan now? Now we came up with this particular scan entries. Why need a scan? So I have my node IPs, and node IPs will not survive my failover. So I came up with this VIPs. And then since VIP is able to do a load balancing using this load_balance equal to S, and also doing that failover and all. But then why we need this scan? And Oracle came up with the scan. Why we need this scan?
So
yeah,
the scan actually came into the picture. Like if we are like in the background, we are adding or removing any node in the cluster. So we should not make an entry. on the in the JDBC or any on the application connectivity side.
Right, right. That's absolutely right. So why scan came here? Two advantages. One is uh, client side high availability and server side load balancing. Uh, Client scan will act as uh, two major activities. One is client side high availability, client connection high availability, and then server side load balancing and ease of application management or ease of database administration. So what that mean? These three features with the scan. Uh, Assuming that you have node 1, node 2, and then your application is configured using this particular TNS entry. And then later after certain days, your business is increasing and then you have added the third node here. Like, I can say node 3. You added this node 3. And then what your application team has to do, they had to add this node 3 details into the TNS files, address, protocol, TCP, host, and they have to put that third node VIP address and then port number. They have to add that third node into their application and they have to reconfigure their application. How they will reconfigure the application? They might be using JDBC, they might be using ODBC, they might be using TNS connections, or whatever the ways they configure their application, they have to reconfigure their entire application by adding this third node details into their TNS files or the JDBC connection files. That's become tedious. Reconfiguring application needs entire downtime and nobody can in the real time world, they will afford. And then again, certain days, your business is again growing. You're going to add one more node. That's your node 4 after 6 months. And then again, your application team has to reconfigure their entire application, right? By adding that fourth node IP address and VIP details. Again, that's become a tedious. So that's how like manual effort. They have to again and again reconfigure their application. So that's one of the disadvantages of using your VIP in their application connection. And assuming that your application, your business is going under loss, and you unnecessarily don't want to pay the licensing, and you're gonna remove few of the nodes. Like I want to remove this node 3 and 4 from my cluster. The moment you remove this 3 and 4, and your application team has to remove that fourth and third and fourth IP addresses from their connections, their configuration file. Again, they have to reconfigure their application. Again, the downtime. So these all manual effort. They have to reconfigure their application and again and again. And then you have saved this particular TNS entry with this node 1, 2, 3, 4 details to thousands of clients who are connecting via client from their desktop or laptop or from that client TNS connections. So to all those thousands of users, you have to communicate. Instead of this 4 node VIPs, you have to remove the true, and you have to use only 1 and 2. And then all those thousands or hundreds of users has to change their TNS files inside their client machines. So that's also become tedious. So in order to avoid all of them, Oracle came up with this scan, single name. So the scan, client can connect using the scan. The scan will internally pass the connection to node 1 or node 2 or node 3 or node 4. And the client or application no need to add those VIPs or add those node IPs. Just a scan name they can use. Scan has an internal mechanism inside your cluster where scan can route the connection to node 1, scan can route the connection to node 2, scan can route the connection to node 3, or scan can route the connection to node 4. And later you can add one more node, fifth node. You no need to reconfigure your application. You no need to inform those thousands of users to add that fifth node details. Automatically they're using a scan, single name, single host name, and then scan can route the connection to fifth node in your cluster. The moment you remove few of the cluster nodes, scan will be aware of that. Okay, I removed 2 of my cluster nodes. My cluster is having only 2 nodes. I can route connection to node 1 and 2 only. I no need to route the connection to 3 and 4 because they are removed. So that's one of the advantages. The scan knows that intelligently how many cluster nodes are part of my current cluster. If they added a new cluster, automatically my scan knows. If they removed the node from cluster, scan knows that. That is one of the major advantages. Scan will avoid reconfiguration of your application whenever a reconfiguration of your TNS files in your client machine, whenever you add a cluster node or remove a cluster node. That's one of the major advantages of using a scan. And the second advantages is your client side high availability and server side load balancing. So client side high availability is like, as I said, scan will be having these 3 IPs, right? Scan will be having these 3 IPs. If I put it here, these 3 IPs, and your first client connection comes, and then your C1 client, this particular C1 client will connect to scan. Scan internally route the connection to using this IP1, and it will connect to node 1. And C2 connection comes, you will be using the scan. Scan internally route the connection to IP2, and it will route the connection to node 2. And C3 connection comes, he will be again using the scan, and then it will go to third IP, and then it's gonna go to any of the cluster node. So there are 3 IPs for the client. If the client 4 comes, and he will be again using the scan will go to node 1. The node first IP is not available, it will go to second IP. Second IP is not available, it will go to third IP. It's kind of a high availability for the client connections, right? So if they're using the node 1 VIP, if the node 1 VIP goes down, the client will be having a one type of check, right? Like one IP is not available, there's no second retry option here. But when you're using a scan has a 3 IPs. The moment the client connection comes via scan will try to connect using one of the IP. If that IP is not available, automatically go to second IP. If the second IP is not available, automatically go to third IP. So it's kind of a high availability for the incoming client connections. That's the second advantages of your scan. And the third advantage is your scan is smart enough, or scan knows which node has how much of load. Like node 1 has 40% of load, and then node 2 has 10% of load, and client connection 1 comes, the scan automatically route the connection to node 2, and the second connection comes, scan automatically route the connection to node 2. Third connection comes, scan automatically route the connection to node 2, because your scan node 1 is already having 40% of load, and node 1 has only 10% of load. So up to that 40% of load, the scan is smart enough to send all the incoming connection to node 2 only. Once the node 2 become like more than 40%, and then automatically next connection will go to node 1. So that's an internal mechanism how scan will handle that load balancing across your cluster nodes. So that's a third advantage of using your scan. Hope any questions on this one? Your physical IP, your VIP, and then the scan IPs.
So from where it will identify the load of this each node, because scan will route according to that load only, right?
Right. So there is an internal mechanism. Each of those cluster nodes, the respective PMON process will register into your scan that so and so time in my server these many connections, and this is the load it is having. So your respective PMON processes will register the load information into your scan.
Okay, PMON will take care. Okay.
All right.
Thank you.
Let's clear it out. Right. So I hope this is clear about physical IP, why VIPs, and why scan. And then this scan came in 11G release. No, sorry, this VIP came in 10G release 2, and the scan came in 11G release 2. I'm not sure about that versions. I can once we start, we can talk about that. Yeah, that's how these are the advantages of your scan and your VIPs via rather than your physical IPs. Right. So,
Malik, I have one more doubt. By using VIP or else physical IP, if it is unavailable, what is the error message we are get?
It's unavailable. There are certain logs you can go and check it out what error message and how it is.
No.
Sorry, I lost you. Hello.
Is resolved like that. What is the error message we are facing?
No, like if it is not available, they won't get any error message because your scan will take care of that connection, right?
No, if we are given the connection string as VIP to end user. At the time, what is the error message? If we configure scan automatically rerouting to next available.
Right.
So what is the error message we are getting? Then only we have to know that this node is unavailable. So that's what it automatically from next next attempt at that time only it is going to connect another node, right?
No, I did not get that. Come again.
When we try to connect the database instance 1, at the time node 1 is getting failed, we are getting one error message, right?
Right.
At next connection, when we try to initiate the connection, automatically goes to another node. During that time, what is the error message we are got?
It depends like what whether TNS lost connect or your scan cannot resolve the connections. If they're using a scan, they may usually get the TNS lost contact. That's a common error message. Most of the time we can get it, irrespective of whether using a VIP or the scan IP. If the IPs are not able to communicate or not able to route the reach the connection, so obviously that's a common message, TNS lost contact, that error message. And in the next attempt, when the connection is established, so you can automatically connect it without any error message.
Okay, thank you.
The TNS lost contact, that's a common error message. You can see most of the cases, whether it's a VIP or the scan. Even sometimes your scan also will not be able to reroute it due to some network or whatever reason. So in that case, that's a common error message. You can see TNS lost contact.
Okay.
Right. Yeah, this is high level. At application side, you're going to give scan, and the moment any of the end user connect via scan, they will be using VIP. Via VIP, they will connect to that respective node. From that node, they will be able to access the database. And each of these node 1, node 2, node 3, node 4 will be communicating via this cluster interconnect. We can say that's your private network. You can see this is ending with this 2 dot. 2 dot is your different subnet. That's your private network. So your cluster communication and your database communication, that will happen via your private interconnect. Right, and then your scan VIP, your node VIP, your node IP, all these three IPs, scan, VIPs, and your node IPs, all these three will be in a public network. They will be like publicly accessible outside of your network, outside of your domain, because these are in public network. But whatever this private, it's a cluster interconnect, we can call it as. So that will be not accessible outside of your domain, like it will be internal. You can access only internal to your domain. That will not be able to accessible to outside of your network, since that's your private network.
So, sir, what will be the network flow of the user? Like first you connect to the scan, and then the scan will pass the connection to the local listener,
right?
Or VIP.
Right. Local listener will be configured with your VIP. That's a mandatory. You have to configure with your local VIP, and then your scan will pass the connection to your local VIP, and then local listener via VIP, and then the connection will be established to your database.
No, can you just like make some draw and explain the flow of the connectivity?
No, like
how does user connect?
It's a simple thing, right? Like you have a scan listener at your cluster level, and then they will be using your scan TNS details. The incoming connection will go to that scan first. The scan internally pass to your local listener, and the local listener will pass to your database. That local listener will be configured with your node VIP. That will be here. So your end user will connect to your scan. Scan will be having a 3 IPs, and it will be default having a 3 listeners. The scan listener will pass the connection to that local listener. That local listener will be configured with your local VIP of that node, and then via that local listener, it will gonna connect your the respective database.
So, what is the role of the VIP here?
What's the role of the VIP
in this connection flow?
Yeah, if you are using a scan, ideally need that VIPs are like useless here. If you're using a scan, the VIPs are like useless here.
Useless.
Right? Useless.
Okay.
Because like that's how Oracle has came up with. In order to achieve this failover concept, they came up with the VIP, and then later that VIP cannot handle this cluster modification, right? Adding a node, deletion node, and then Oracle came up with the scan here. And then once they introduced the scan, your VIP become redundant, because scan has the ability to pass the connection to any one of the cluster node with intelligently load balancing and all. But your VIP become redundant, like, useless, but still it's a part of your cluster. You have to provide your VIP details.
Okay.
And then like for example, right, once your connection come to scan will hand over the connection to your particular node VIP, and then scan will go off. And then the node will take that incoming connection, node particular listener, and then it will connect to via that particular VIP. And then this particular listener also will go off. And then once the connection is established here, and then that particular node VIP via node VIP, all the communication will happen back. When he's querying the data, all the data will be pushed back via that particular node VIP. If that node is VIP goes down here, then who is going to send the data back to that particular end user or the end client, right? And then when this particular node goes down, that VIP will be shifted back here. Why that VIP will be shifted back here? Only to failover if the 10 connections are coming here, connected here. So 10 connection has to be failed over from this node to this node. How that can be achieved? Only using that VIP. That VIP will be shifted here. Automatically the VIP, the moment you shift the VIP, all the 10 coming connections, whatever are attached here, all those will be like shifted to this particular node when the VIP is failover happens.
I got it. One more thing, sir. Is the node VIP bind up with the local listener?
Yes, that's how you have to define.
Okay.
You should not define with the physical IPs, physical.
So the flow would be like from the client side, I'm just connecting it to the server. Like first it will go to the scan, then it will go to the node VIP, then it will go to the listener, local listener.
Right.
The local listener will connect to the database server.
It will not go to that local VIPs. If you're talking about listener, you have to talk about listener. Don't bring the IPs. Like, client will connect to scan listener. From the scan listener, it will go to local listener. From the local listener, it will connect to database. So at the backend, what you need to understand, from the client, it will go to scan IPs. From the scan IPs, it will go to node IPs, node VIPs. From the node VIPs, it will connect to your database. That's how the flow is. The listener means it will be default your VIPs, not the physical IPs.
Okay, I understood. Thank you, sir.
Right.
So does it mean that when the failover happens, node goes down, the along with the VIP listener also switches to another node?
Listener will not switch. The local listener will not switch. Your only scan listener will switch. So I'll tell you, like, what's the confusion here, right? Assuming that you have this 3 IP, right? Let's go back here. You have this 3 IP, 105, 106, and 107 here. Let's take it here. You have 3 scan here, 105, and then 106 and 107. And then you have this 10, this is your 101, this is your 102 physical IPs, this is 103, this is 104. So you have 101, 102, 103, 104. These are your physical IPs, and 5, 6, 7 are your scan VIPs, and then you have 6 after that, 8 and 109 and 110 and 111. So these are your VIPs. You have to configure your local listener under your VIPs. Why we need these VIPs? Like, this particular client will come here, it will go to scan, and then it will go to this particular 109 VIP, and then it will connect to this particular node here. And then the moment this particular node goes down, and this particular 109 VIP will shift to here, 109. But your scan will not fail over. The local scan, local listener will not fail over. Only that VIP will fail over. So since this VIP will fail over to this particular node, and this particular node has 10 connection, all those 10 connection along with this node failover, all the 10 connections will be like established here in this particular node, right? And then why the VIPs, why the listener will not fail over to this particular node? Because you are already running one listener here. And then if you try to fail over this particular listener here, 109 listener, and then once the incoming connection goes, automatically you have one already listener to handle that incoming connection here. And then your scan will never route a connection to this 109 listener, because it will mark internally your cluster, this particular node is down. So any new incoming connection will never go to your node second here, because that listener, it will automatically bring it down, and the node will be marked as a down inside your cluster. So only that particular associated VIP will fail over to that node. Why that VIP will fail over? Because it has to bring that 10 connections, whatever that established, all those 10 connections has to be failed over. That will be part of your VIP failover. The listener will never fail over, the local listener. We know that, again, go internally, some more concept here. We know that node 1 listener will run on node 2, node 2 listener will run on node 2, node 3 listener will run on node 3, node 4 listener will run on node 4. How about these 3 scan listener, where they will run? They will run any of this cluster node. Any of this cluster node. Not mandatory this has to run on here, this has to run on here, this has to run on here. This cluster, this scan will run on any of these cluster nodes. Right? So that's about VIPs and the listeners, scan listener and local listener. And then your failover and the client connection, what we discussed. And going again, some of the storages, your OCR and voting disk, all will be part of your ASM, will be stored inside ASM. Clusterware files in prior to 11G release 2, in 11G release 1 and 10G release 2 and all, we used to store it locally under that particular node. Your OCR, voting disk, everything, we used to store it under locally of that respective node. But starting with your 11G release 2, we started storing your OCR, voting disk into your ASM. And then your HBA, typically it was the old version, like 2G to 4G. Now we are supporting 10 giga or 20 Gbps or 40 Gbps. When it comes to in Exadata, we recently came with a Rocky switch, which is 100 Gbps bandwidth, what it is supporting in Exadata.
Sir, just need to understand the Clusterware file, that is a OCR and voting disk. But now in 12C and 19C, both are the combination, like combined in a one file. Okay. So this Clusterware file can't be on ASM prior to 11G or 2. Okay.
No. What you said in 19C, voting disk and OCR?
They are combining in a one file, right?
No. Who said?
Actually, it goes to one disk. That's
no, you can have different disk groups. You can have voting disk is a separate part. OCR is a separate part. They cannot be combined together. And you can store OCR into separate disk group, voting files into separate disk group.
Okay, but while the installation of 12C and 19C, we store in the same disk group.
Yeah, because that is the minimum requirement. Even in 11G, even in 12C, even in 19C, while installation of Clusterware, it will ask you to enter only one disk group. You're going to give one disk group name, and your voting files will go to the same disk group. Your OCR files also go to the same disk group. Later, you can push it to some other disk group. There is no restriction at all on that.
Okay.
But these two are separate files. OCR is a separate file. Voting disk is a separate file.
So, what is the OCR file and voting disk file, sir?
We'll talk on that in a minute.
Okay.
So, and then supported
Sir,
storage. Yeah.
Sir, going back in time, from which version Oracle has supported this clustering?
Supported this?
This clustering method. Like
10G.
In 10G release 2, like for example, in 10G release 2, we used to install ASM home separately. ASM home, and we used to install, sorry, in prior to 10G release 2, release 1, in prior to 10G release, in prior to 10G release 2, I'm not particularly about that, but in 10G release 2 onward, till that 11G release 1, we used to install ASM Oracle home separately, for example, U01/ASM. And then Clusterware software was separate. We used to install like U01/ /cluster, like something we have to install 2 separate binaries and then form your cluster nodes. And then later we used to install U01 Oracle Home and then create your databases. But in 11G, I think 11G release 1 onwards or release 2, I'm not sure on that version. Oracle has combined this particular ASM home, cluster home together, and they made it as a grid. And then now we are installing only single software U01/grid. The moment you install U01 grid, it will automatically set up your cluster, automatically install your ASM home in the same folder, same directory.
So clients who are using those 8i, 9i, all those versions, they cannot get this high availability service, right?
No, high availability came in which version?
Active passive we used to do that active passive in 9i.
Right. And that used to serve the same thing, like it was used for high availability only.
Yes, but it will be not like both. Like in this cluster, what happens? Your all the cluster nodes are available, and then the your all the incoming connections are equally distributed, and it's kind of a high availability. There are multiple channels high availability. But in 9i, prior to 9i or 9i, like we have a parallel server OPC, and then later we came up with this active passive connections. And then that needs a lot of manual intervention. Like when the node goes down or connection goes down, you have to manually bring it up. A lot of older days, and started with your 11G, 10G release to onwards. They came up with this clustering concept with the high availability, and in 11G they combined this cluster and ASM together, and they made it as a this particular grid infrastructure.
Yeah. Okay.
Right. So what are the supported file inside your ASM disk group? All your whatever recommended data file, SP file, control file, redo log, archive log, flashback log, your dump files, your BCT, your voting disk, OCR, everything you can keep it inside your ASM. Yeah, we'll skip this background process. We'll cover it as part of our actual course. GCS Global Cache Service. One of the main we can many interview they will ask what is cache fusion. Cache fusion is like transferring the block between 2 cluster nodes. For example, I have node 1 and I have node 2. Client 1 connected to node 1 here. He did a select star from employee, and then where employee ID equal to I can say 100. So 100, whatever that employee ID 100 information he queried in this node 1, and then whatever that from the storage level employee table, what that 100 employee information that block has came, and in the SGA of node 1, right? That information about employee ID 100, all the salary, address, all those details will be kept under this particular block here in the node 1 SGA. And client 2 connected to node 2 here, and then he is also querying the same thing, select star from employee where employee ID equal to 100. So that client 2 connection will never go to disk to fetch that employee details, because employee details are already available inside the memory here of the node 1. So client 2 will directly request for that data, and the node 1 will send that data, employee ID 100 data. It's a buffer to buffer, your database buffer cache to database buffer cache. The data will be transferred here, and then the data comes here, and that will be given to that end user. That is your cache fusion, the transferring the blocks between your node 1 to node 2, or like between your cluster nodes from SGA to SGA, or from database buffer cache to database buffer cache. That's your cache fusion. So we'll talk more on that. Yeah, that's a cache fusion. That's a commonly asked question in the most of the interview. And in order to achieve this cache fusion, there are a lot of background processes, LMS.
Sir, how it will transfer, sir, that data buffers?
That will be with the help
cache.
of your interconnect. There's a private interconnect. We talked about we talked about public connections, public network and all. And then why we need this private interconnect, private network. That network is for your node communication to transfer the data between your node 1 buffer cache to node 2 buffer cache. So your private interconnect, whatever this network will comes into picture here. Via this network, all the data will be transferred here.
Okay.
And again, this cache fusion, everything will be like managed with the help of many background processes. Few of them are your locking services, LMS, LMD, and GS, Global NQ Lock, LMON, and LCK. So these are your locking processes in your RAC system, which will help to lock a particular data. And it's not about, for example, if I, in simple words, if I want to explain, I have two connections here, node 1 and node 2, and client 1 connected here, client 2 connected here. And then I have a table data here, employee table. And then this particular client 1 is updating employee ID 100. And then employee ID 100, he's updating here. He's making salary from $1,000 to $2,000. And at the same time, if this client 2 connected here, even he want to update same employee ID 100, where he wants to make the same salary 1,000 to, he want to make it to 3,000. So if this guy also update the same record, and if this guy also update the same record, what's the use of your data concurrency, right? So when this client 1 is updating your employee table, and then client 1 will put some locks on that particular table, so that client 2 or anybody connected from the other cluster nodes or the same cluster node, they will be like notified. Okay, already the lock is kept on that particular table, on that particular row exclusive lock. You cannot modify that particular row of this employee ID 100. So with the help of your GS, Global NQ service, and LMD and LMS, we'll talk on that. These are the background processes which will put the lock of the respective row with the exclusive mode or with the transactional mode, and then it will not allow others to modify the same records. Right, so those are like your RAC specific locking mechanism. And yeah, some more information, basic things. Your redo logs, control files, database files, server parameter file, password files. These are like basic definitions. And then we talked about voting disk. And voting disk, you can do this CRCTL query, CSS vote disk. We have only one voting disk because it's an external redundancy, not a normal or not a high. We have one voting disk for this cluster setup here. Ideally, if it's a normal, you can have 3 voting disk files. And if it is a high, you have 5 voting disks. That's a default. Again, in 11G release 2 onwards, we started keeping your voting disk inside your disk groups. One of the common questions is, what is voting disk? Why we need voting disk? Voting disk is basically, like 2 things here. Like one is your network heartbeat and disk heartbeat. What's a network heartbeat? Network heartbeat is your node to node communication. For example, node 1 will ping node 2, and node 2 will send a response to node 1. And node 2 will ping node 1, and then node 1 will send a response back to node 2. So both the node will ping, okay, I'm available as part of my cluster. Are you available? Just it will ping or TNS ping, or the network ping, I can say. Not a TNS ping, network ping it will do. And then within a specified second, I think, I'm not sure about how many milliseconds, your node has to respond it back. So that if the node 1 will ping node 2, if the node 2 respond back, then node 2 is part of cluster. If the node 2 will ping node 1, if the node 1 is not sending any response back to node 1, the node 1 will be evicted from the cluster. That's we can say that network ping. And then it is like node to node communication. And at the same time, we'll be having a storage, and we'll be keeping our our voting disk here inside my disk group. Node 1 will go on every 1 second, 2 seconds, 3 seconds, there's a specified timeline interval. Node 1 will go to your voting disk, and node 1 will register, okay, this is a timestamp, I'm available, I'm part of cluster. And then node 2 will also come, it will register inside my voting disk, okay, this is the timeline, I'm available, I'm part of this cluster. Node will regular interval, they will register inside my routing disk that, I'm available, I'm part of cluster. So if this particular node is not able to communicate to node 1, this node will be evicted from the cluster. If this node 2 is not able to communicate to my routing disk, this node will be evicted from my cluster. So again, there are certain scenario on what basis node will be evicted. Who is going to evict? For example, uh, again, take one more example here, node 1 and node 2. Node 1 pinging node 2, node 2 is not responding. Node 2 pinging node 1, node 1 is not responding. So whether I can evict node 1 or whether I can evict node 2, don't know. So that will be decided based upon the split brain syndrome and with the help of my voting disk. So in voting disk, we have Oracle recommended to keep odd number of voting disk. Why odd number of voting disk? In order to avoid this split brain syndrome. And again, commonly asked interview question, what is split brain syndrome? Split brain syndrome is like, node 1 is not able to communicate to node 2, node 2 is not able to communicate to node 1. In that case, both the node will act as a independent cluster nodes. And then, your clusterware has to evict one of the cluster node. How to evict that cluster node? Based upon your voting disk. So whichever the node out of these two return a majority of the data into your voting disk, so those will be retained, and whichever the cluster nodes are return less data into your voting disk, those will be evicted from your clusterware. So that is called simple majority rule. So again, simple majority rule will be calculated based upon the number of voting disk, and Oracle will recommend to always keep odd number of voting disk, 3, 5, 7, like odd number of voting disk. If you keep a even number of voting disk, so when the split brain syndrome, there is no way you can determine which cluster node to evict. If you keep a odd number of voting disk, you can easily determine which cluster node has written a more data into voting disk, which cluster node has written a less data into voting disk, and based upon that, whichever the node is written less data, cluster will evict that particular node from your clusterware. That's these are the different concepts. We'll explain more on that. Voting disk, simple majority rule, why we need a odd number of voting disk, what is split brain syndrome, what is cache fusion. So this we'll discuss further more once we start. But these are like commonly asked questions you can expect in any of the interview. What is simple majority rule? What is split brain syndrome? What is voting disk? What is cache fusion? And why we need a odd number of voting disk, right? Yeah, simple understanding. Voting disk, why we need each cluster node will register into voting disk that, so that they will be marked as available in the cluster. You can query this one, crctl query CSS vote disk. You can see that how many voting disks are configured.
So cluster information will be available in voting disks, sir?
No. The cluster information will be available in OCR, Oracle Cluster Registry. Voting disk, as I said, it will be like just a node information, and all the node will come and register. Okay, so and so time, this is the time 9/7. I am part of cluster.
Okay, time stamp of. Okay.
Yeah.
So by any chance, voting this is externalized by any viewer, or somehow can we see what exactly it does, or it's like a buffer or circular buffer, or how?
No, your voting disk is your binary format, right? It will be written inside your disk. There is no way you can read the content of voting disk, but however, there is some OS utility called kfed. By using them, you can read that what is the content of your voting disk. Right. So coming back to your OCR.
Sir, one more question with respect to the voting disk.
Yeah.
So is there any time limit for the OCR and voting disk? If my node is not able to communicate within this nanosecond, then node will be evicted. Is there a kind of limitation is there?
Right. There are like we can call it as a CSS miscount. We will talk on that. There's a CSS miscount. You're going to set it to 1 millisecond. You're going to set it to 1 minute. The moment that much of time it reaches, the node will be evicted. Default, I don't know. I cannot remember on top of my head at the moment. So but once you start,
what is the best practice? So like how much time should be there?
No, default, nobody will change that. Once you set up your clusterware, nobody is change that. Your network ping time and your voting disk ping time. Nobody will change that one until unless it is recommended by Oracle due to some criticality. By guidance with Oracle only will change it, but otherwise, most of my career, like I never seen any customer is going to change that timeout option for your voting disk and your OCR.
Okay, sir. Thank you.
Sir, is that being driven? I mean, is there any contribution here for the MTU value?
No,
here?
no.
Okay.
Right. So your OCR, Oracle Cluster Registry, all the cluster information will be available inside your OCR. Cluster information, whatever your VIPs, whatever the scan, all those will be part of your OCR. It's a cluster level registry. You can go inside your ETC Oracle and you can see that particular class ETC Oracle. And then you can see your OCR and OLR here. I can just check for my OCR first. This is my OCR file, location ocr.loc. If you took cat on that, your OCR config location will be your plus data, your ASM, this is the plus data disk group, and then this is your registry file. This is your OCR file. And if I go to other node as well, node 1, and if I go to node 2, if I go to node 2 and then node 2 also, if I check my OCR file, plus data, and then the same file. And then it says local only equal to false because we cannot save OCR file locally. So here also with that, okay, we not mentioned that here. We never mention OCR file locally on that particular node. Everything will be still under
Is
saved.
file name same sir or different?
You can verify this one, right? 197,
Same.
107. But again, doesn't matter whether it's same or not because whichever the cluster master node, you can go ahead and check that particular node. That will give you, for example, I can go ahead and change this particular file here. I can go and I can edit this one, and then I can change it. But that's not going to impact here. But whichever cluster master node, that will automatically update your OCR location here because it has to take a backup on regular basis.
How to check which one is master node and which one is slave node?
I can explain that. There's so many ways you can configure that. One is your work column, and then you can get master is one of the command that you can verify. Yeah,
Can
there otherwise.
show that.
I'll check it out. Okay. Yeah, I'll show you that in a minute. One is that one. You can check this OCR file location, and the other one is your OLR, your local registry. So your local registry will be inside your. Wait a second. This is your. I'll go inside this one. So this is your CRS home and your OLR config. This is your local registry here. If I go, and then this is the backup it's going to take. This is your particular OLR. This is particular to this particular node. OLR stands for your local registry. It will have only information particular to this particular node. Whatever this node name, node IP, and what are the services running from this particular node. This is the file, very first file, which will be read when your cluster OHST service will start on this particular node.
Is this readable?
This is the binary file. You cannot read that.
Oracle local registry is the first file which read by Oracle cluster when it is start.
Oracle high availability service OHST process will be read by this one.
Okay. Thank you, sir.
So OLR is having only particular node information, sir?
Yeah, that particular node information.
Oh.
Right. So this is OLR, which is your 11G release 2, an additional component for OCR. Even though you have OCR, OLR came into picture. That OLR has only information for that particular node. When you start your OHST service, it will read this OLR and it will start all the services which are supposed to start on that particular node. So these are the common questions here. Your OLR stores, what is your OLR contains, and what is my OLR location? What is my OCR contains, and what is my location for my OCR? Right. So OLR and OCR are mandatory things um, in order to start your Clusterware. Right. So I can quickly, instead of startup here, I can quickly show few things here. I'll jump into the startup in a minute. Let's go here. Right. So few of the things, right, in the RAC administration, uh, what we're going to do, CRS-CTL versus SRS-CTL. So with the CRS-CTL, you're going to do at your cluster level administration. With SRS-CTL, you're going to do all your database level administration. For example, SRS-CTL config database, and you can check your database status, SRS-CTL status database, SRS-CTL stop database, or you want to stop a particular instance, SRS-CTL status instance, and stop instance, start instance, and if you want to change any of the resources or change your listener parameters or configure your listener, all this at the database level, you can use your SRVCTL. A few things I can quickly show here, and then we can jump on that Clusterware startup. So I can go for this test database, which is Oracle is the owner. I'll just log into Oracle user. I can set the environment to my test DB. So I can simply run this command srctl status database -d and my database name. So you can see it is running on both the nodes. It's a 2-node cluster, and you can do srctl config, and then you can check the configuration for that particular test DB database at the high level. Where is your SP file? Where is your password file? What is your start option, stop option, and your service name and your database instances, where it is running. All this you can see it here. And you can stop your database using srctl. srctl stop database. It's going to stop your database on all the nodes. You're going to do stop database. Instead of the stop database, you can do srctl stop instance and your database name and your instance name. So you can stop instance 1, instance 2 from any cluster node. You can connect to node 1. You can stop your node 2 instance, node 3 instance, node 4 instance. You can connect to connect to any one of the instance, and you can stop it from anywhere. That's your SRCTL at high level. You can manage your database. And at your cluster level, you can use your CRSCTL, stop cluster, start cluster, and all those things. There are two concepts here when it comes to Clusterware. One is your HAS and one is your cluster services. What I can show you now, your database was down now. I can simply show these things here. CRSCTL, check cluster -all. So I'm doing a CRSCTL check cluster all. You can see your cluster ready services, cluster synchronization service, and event manager service on node 1. And same thing on node 2, cluster ready services, cluster synchronization service, and event manager service online. These are 3 your cluster level services. But however, if you do CRSCTL check CRS, so you are going to see 4 services here. Your cluster ready services, synchronization service, and event manager. These 3 are your cluster level service, and your Oracle high availability service is a local on that particular node. Same thing if I go to node 2 and then set the environment to ASM2, I'll run the same command, CRSCTL check CRS on node 1. I'm going to get these 4 services. Your OHSD, this is your Oracle high availability service. It's a local on that node 2. And these 3 are your cluster level. So if I run the same command here, CRSCTL check cluster all, it will going to check only your cluster level services. You can see these 3 services on node 1 and these 3 services on node 2. So what I mean to say here, this is my node 1 and this is my node 2. And then I have something called Oracle High Availability Service, OHST, local to this node 1. This is OHST is local to this node 1. And then we have Oracle High Availability Service and local to node 2. This is again local to this node 2. And then apart from that, these three services, your CRS, your synchronization and event, the remaining three services are what I can say at your cluster level. So these three services are a cluster level. So you can connect to node 1 and you can shut down these three services. The three services will be running here and then these three services will be running here, right? You can shut down, you can connect to node 1 and then you can shut down these three services. And you can connect to node 1, you can shut down these three services because those are cluster level. You can connect to any one of the cluster and you can shut it down. But in order to shut down this OHST, you cannot connect to node 2 and you cannot able to shut down node 1 OHST. You cannot connect to node 1, you cannot shut down your node 2 OHST. In order to shut down your OHST, you have to connect locally on that particular node and you have to shut down because that's a local resource, right? Why I'm explaining that one, commonly asked question, right? How I can shut down my Clusterware. This is how it works here. I can put it down here. Right. So you're going to do, I'll just connect to node 1 here. I'll just connect to my node 1 here. And the moment I do this CRSCTL stop cluster all, what happens here? The moment I do CRSCTL stop cluster all, it's going to eventually shut down my 3 cluster services on node 1 and these 3 cluster services on node 2. Node 1 and node 2, your cluster services are down. But your HAS service will be still running on node 1 and node 2. You have to individually connect to node 1 and node 2. You have to stop your HAS services. CRSCTL stop HAS on node 1 and CRSCTL stop HAS on node 2. That's your complete shutdown of your cluster. You have to do 3 times. One is stop cluster all on node 1 and stop HAS on node 1 and node 2. You have to run 3 commands in order to bring down your entire cluster from both the nodes.
Sir, this HAS means what? Huh?
It's a Oracle High Availability Services on that particular node, which will I'm going to talk about that once I start our cluster startup sequence, why we need this HAS. I'll talk on that. So this is a very basic service. First service, it will get started once you start the cluster on that particular node.
Okay.
Right. So this is how you need to shut down your entire cluster. It's a complete downtime. You have to do this CRSCTL stop cluster all on node 1. And then that's going to shut down your 3 cluster services on node 1, 3 cluster services on node 2. But your HAS will be up and running on both the nodes. You have to do this CRSCTL stop HAS on all the nodes. Then you will shut down your cluster. Rather than that, if you want to start your cluster, CRSCTL start HAS on node 1, CRSCTL start HAS on node 2. It will bring up only HAS services. And again, in order to bring up your Clusterware, CRSCTL start cluster all from node 1. You're going to bring up all the remaining 3 cluster services on node 1 and node 2. You can follow this one. This is your shutdown, complete shutdown I'm talking about. And then this is your startup, complete shutdown and startup of your cluster. Right?
Sir?
Yeah.
Sir, we have a disable and enable option also, right? With the CRSCTL.
I'll talk on that. What is a disable and enable? Not at the moment. This is for the shutting down your entire cluster I'm talking here. You have to do 3 commands in order to shut down your entire cluster, 2 node cluster.
Oh, but if we disable it, will that eventually will stop the HAS process? That is what my concern.
No,
okay.
No, it will not start.
Sir, very quickly, this CRSCTL stop hash, it will stop the Clusterware on both the node or only on the node where I have fired it?
Right. For example, you remember, right? Like for example, let's see here, CRSCTL stop HAS. What happens here, right? Again, I'm going to coming to that one, right? Let's draw it here. So your node 1 in order to start your dependency will be like your OH, or else I can make it as HAS. HAS. After HAS started, and then all the remaining three, that whatever I showed, right? Three service will be started. So the moment you stop your HAS, eventually it's going to bring down all these three services. You understand, right? Because these three services are depend upon this HAS. Right?
Oh, okay. Okay. So basically, CRSCTL stop hash and CRSCTL stop cluster is same
right.
command.
Okay, CRSCTL stop cluster will bring down only the three services.
Okay.
These three. So
Okay.
these three services will be bring down by this stop cluster. It will not bring down, but HAS will not go down. You have to run this HAS again.
So HA is some other background processor.
Right. That's a completely background process, the different background process.
If you
All
can
these
show
three,
that.
I'll show that one. See, underlining factor is that, for example, let's clear this one, right? Let's talk about this one. I want to bring down my node 1. How you will bring down your node 1? I want to bring down all the cluster services on node 1 only. So in that case, you're going to do this node 1 only. I'm talking about node 1 only. So I'm going to do stop cluster on node 1, and I'm going to stop HAS on node 1. So it's going to bring down my entire services on node 1. And then I want to bring down my node 2 only. So I eventually have to do this stop here, right? It's only bring down all the three services. There were synchronization service, CRS, and then your event manager, three services, right? You're going to bring down, and after that, you're going to shut down your HAS, because HAS is the basic service you're going to get started. After that, all the remaining three services will get started. So in order to bring down your all cluster services on node 1, you have to stop cluster on that node 1, and you have to stop your HAS on node 1. Similarly, on node 2, you have to stop all the cluster services, and you have to stop your HAS. This is like, node 1 stop, and this is node 2 stop. Rather than that, you can do stop cluster all. It's going to stop your all the cluster services on node 1, this one and this one. Rather than running these two commands, you're going to run this one single command here. Right? And then after that, your HAS, you have to manually bring down on all the clusters. The same command, like, you are going to do at your cluster level, or you're going to do at your individual node level here.
So hyphen all option will stop the three
your cluster services on all the nodes
or processes on both the nodes,
right?
All the nodes, but it will not bring down the HAS. HAS I have to still go and manually bring down the HAS on both the nodes.
Right.
Okay.
Right. In order to start that services, you cannot start your cluster directly. Why? Because it has underlying HAS dependency. You cannot do this one. Rather, you have to do this way. HAS, and you have to start this one.
Malik, I have a question here, Malik.
Yeah.
Malik, I just wanted to know, these are the sequence which are going to say to bring up or to bring down the services, domain services.
Right.
But what are the common challenges? I mean, common issues we face?
No, we talk on that. No, we talk on that, like, troubleshooting, clusterware, startup and shutdown troubleshooting. We can talk on that a later part of the course. But what I'm trying to say here, how you're going to shut down, how you're going to bring up your cluster. So here, shutdown sequence is clear, right? You're going to stop your cluster services first, and after that, you're going to stop your HAS. That's the order you have to do it. And again, note 2 also, you have to stop your cluster services first, and you have to stop your HAS later. And what happens, directly if you do node 1, CRSCTL stop HAS. The moment you do node 1 and node 2, the moment you do HAS stop, what happens? In order to bring down your HAS, first your cluster service has to go down, right? So the moment you do stop HAS, automatically your cluster service also will go down and your HAS also will go down. Right?
So now from 4 to 2 steps only.
Right. So again, ideally, people will stop the cluster and they will stop the HAS. That is also same. And directly you are going to stop your HAS. It's going to forcefully stop your cluster, and also it will stop your HAS. So you can run simple command that also works fine.
So is there any harm like directly stopping the HAS?
No harm at all. You can do this process internally. It will going to run this command. It will going to run this command. You can run 2 commands or 1 command, doesn't matter. There's no harm at all. You can do this, any of these processes. All are like same method. This is like, node by node, you're shutting down. Or if you want to do an entire complete shutdown, you can do stop cluster all. You're going to stop on both the node 1 and node 2, all the cluster services. And after that, jump onto all the cluster nodes, node 1 and node 2. You can stop individually here. Right now, what happened here? CRSCTL stop HAS, what it did, it brought down my cluster services and also it brought down my HAS services, right? With a single command, I'm able to shut down. But if I try to start HAS, what happens? It will just start HAS. It will never start your cluster. You have to start your cluster manually again. Right? If I do CRSCTL start HAS, it will bring only HAS. It will never bring your cluster services after that. Right? Your high availability service started. Other 3 services, it will never start it. You have to start it manually. Right? So startup will be.
What is the role of HAS?
No, we'll talk on that. I'll talk on that. What is the HAS? Why we need? We'll talk. But I'm talking about this sequence now. Now you just understand how you shut down and start up. I'll jump on to that Clusterware startup sequence. Then you will understand why we need HAS. This you have to start HAS, and after that you have to start your cluster. You can start cluster all. The start cluster all will start on all the cluster nodes. Right now it will fail because it is already running on your second node. But it's going to start only on your node 1. Like for example, if I do psf grep HAS and then d.bin. Right. So, okay. Other part, like, I can remove this one. Right. So how you do your HAS stop and automatically you start your HAS internally, all the remaining cluster services will get started here. You can see your ASM and this one. But what I'm trying to say here, there are various methods in order to stop your cluster via node wise or via cluster wise, and you can follow whatever you feel it's a better and you're comfortable with that. So one way is node 1 stop, and this is again one more thing. You can do this method or this method, and this is node 1 stop. You stop cluster first and stop HAS later. And you can directly stop HAS. Internally, it will stop your cluster. This is a node 1 stop. And this is a node 1 start option. Where is that one? I'll put it here. Right. So this is your node 1 stop option. And this is your node 1 start option. Right. So, but you cannot do this option here. If I want to do this one here, start cluster, start HAS. If you try to, the moment it supported this stop option, if you try to do this one here, it will not allow you, because the moment you run this command, it says HAS is not started. Right? Just understand what I'm trying to explain here. You can stop your cluster. After that, you can stop your HAS. It is supported while stopping. If you don't want to do these 2 commands, you can directly stop your HAS. Internally, this HAS will stop your cluster services and then it will stop your HAS. These 2 are like valid stop options. And in order to start, if you try to start your cluster, it says HAS is not started. First start that HAS. And the moment you start your HAS, this HAS internally, it will start your cluster. Right? You can just directly run this HAS. Automatically, it will start your HAS as well as your cluster. So this option is not supported. You cannot do it here. Stop option is 2, and then start option is only 1 here. Right? And then there's another way. These are your internal, to shut down and start up. But ideally, this is not the best practice. The best practice is CRSCTL stop CRS, CRSCTL start CRS. So you have to use CRSCTL stop CRS and CRSCTL start CRS. These are the valid command to stop and start your cluster services, including your HAS. These are the best recommendations or the valid command. As a DBA, we are going to use this one. The CRSCTL stop CRS, internally it is going to run stop cluster, stop HAS. And CRSCTL start CRS, internally it is going to do start HAS and start cluster. These are the best practices. stop and start. You have to use this one, right? And then in some cases, when sometimes cluster will not go down, and that time we're going to use force command. CRSCTL stop CRS-F. So we're going to use this -force command. So these are your valid or the best recommendations. You are going to use stop command. I'm talking about only on the node 1. So node 2 also is going to be same thing. You're going to use the same command, right? This is about your cluster stop and start. How you're going to do cluster stop and start. And then what we can say here. So is it clear how you're going to stop and start your cluster, which is internally manages all your daemons?
Sir, this is for a particular node now, sir. For all the nodes, we can stop at a time.
Yeah, all the node is like this. Like, all the node, you're going to do this one.
Okay, okay.
So for all the node, and the shutdown is here. Right. So for all the node, CRSCTL stop cluster all. You're going to bring down all your cluster services on all the nodes. And however, you have to stop your HAS manually on all the nodes, because that's a local one. You cannot do it at your cluster command, stop your HAS. So you have 10 nodes. You can run one time this command. It will shut down all your cluster services on all 10 nodes. But you have to connect to all 10 nodes individually. You have to stop your HAS. And then to start up, you have to connect to all the 10 nodes. You have to start your HAS. The moment you start your HAS, automatically that will internally bring all your cluster services. You don't need to run this command again, because the HAS will forcefully bring up all your cluster services. So this is at your cluster level, and this is at your node level. But some people will follow this stop and start sequence. But rather than doing all this, connect to node 1, CRSCTL stop CRS, or CRSCTL stop CRS-F. It will bring down your HAS, your cluster services, and all other services. Sorry for that, guys. And then you can do CRSCTL start CRS. You're going to start your cluster services on that particular node. This is your shutdown and startup, how you're going to do that. Right. So now I'll jump on my cluster here. I can show that one. What I can do now, CRSCTL stop CRS, right? CRSCTL stop CRS. Again, remember, these are your best options. CRSCTL stop CRS, or you can do on node, only on node 1 I'm talking about. Node 1, stop cluster, stop HAS, or stop HAS, any one of this you can do it. Or you can directly do CRSCTL stop CRS. It's going to do the stop HAS, stop cluster for you. So this is the best option, like CRSCTL stop CRS. And then -F is forcefully. So it's going to shut down your all the cluster services here.
Sir, one quick question, sir. Sir, imagine there are two nodes, and we have in one of the node we have stopped the cluster resources and hash. Now we want to start the cluster resources and hash. If we just give CRSCTL start hash, it will internally start the cluster resources also. No need of
right.
Okay. So it is in a way equal to start CRS command itself.
Right. That's correct.
While starting up.
Right. That's correct.
Okay.
But again, those are not the best practice or best commands. So always you have to use this stop CRS and start CRS. That's the best command.
Okay.
Right. So Oracle High-Availability Services stopped. PSIF grep smon done. Like you can see d.bin, the daemons. Nothing is running, and then you can start like CRSCTL start CRS or CRSCTL start HAS. Both will do the same thing for you. So once you start, it will automatically say that your high availability service is started, and you can query CRSCTL start CRS-T -init. So you can CRSCTL stat resource -T -init. So you can keep on monitoring this one. It's gonna tell you what all the cluster resources are getting started. Right now, your CSST is getting started, and now your ASM is getting started. So whichever service is getting stuck, and you have to look for that particular log. Right now, most of the services are online. Now your CRSD is intermediate.
Sir, this -init option is used for what purpose?
This -init will list out all the init daemons which are part of your cluster resources. Whenever you are dealing with your clusterware startup sequence, you have to always look for the init daemon. So these are your init daemon cluster resources which are supposed to start on that particular node in order to form a cluster.
So that means init we should use that option when we are starting the node.
Starting a node or starting a cluster, and which service are getting started the moment you see, right? And if you observe, your CRSD is an intermediate state and it will never get started. It will be an intermediate state for 1 minute, 2 minutes, 3 minutes, 10 minutes. So you have to go and then check your CRSD log. And then sometimes your ASM will be in a starting state and will be in an intermediate state, and then it will never start for 5 minutes, 10 minutes, and then go to your ASM and check for your ASM log.
So can you try one without init?
Okay.
I'll show you that one. So now you can see all the services are came online here, back online. So it means your cluster is healthily came online. Your ASM online, your cluster interconnects online, your CRSD and your CSSD, your CSSD monitor, your CTSSD, and all other services. Everything is online except this diskmon. Diskmon will never be used in your rack. It will be our Exadata feature. It will be always offline. So apart from that, all the services are online, means your ASM is up and running. Your all the database, everything is back online by this time. You can see your databases and your ASM, everything is back online. Right? So once you do a start and stop your cluster, you have to always use this init. Which services are getting stuck? You have to go for that particular log and then check for that resource, why it is getting stuck, what is the cause for that one, right? And if you don't do init, that will be your cluster resource. Like all the cluster resource, it will gonna list out. CRSTL stat resource -t. It's all your cluster resource. Everything is going to get it here. You can see it from here. Your cluster listeners, your database listeners. Sorry for that, guys. Okay, and your CHAD and your network and your ONS and your ASM listener, your disk groups and your scan listeners and your record disk group and your ASM instance, your ASM network and CVE, your node VIPs and your databases and your scan VIPs and your database status and your database services. So it is at your cluster level. If you don't use that -init, it will be at your cluster level. All the services or resource, whatever running, we're going to list it out here. If you are dealing with your clusterware startup and shutdown sequence, you have to use this -init and you have to monitor which services are getting started and which services are getting stuck. Right, go back here all the way. We'll talk a little bit about clusterware startup.
So does that mean -init if we use, it will show all the like mandatory processor?
Mandatory process which are supposed to run on that particular node. So you can verify -init and you can verify grep d.bin. So these are your daemons of services which are supposed to start. These are the respective services for these daemons.
Okay, thank you, sir.
Right. So this is your typical startup sequence. We talked about HAS, OHSD, we can call it as. That is a local to that particular node. That's a very first service will get started, and that depend on your OLR. If you don't have the OLR, it will never get started. Let's see here. If I do this one here, this is my OLR. If I to move it as a backup and then try to start my cluster, will never get started. My OLR will never get started. That's a dependency. Very first thing, the moment your HAS service, you're gonna first your OLR and then it will start, because that's a local, it's not a cluster level Oracle high availability service. Right. So once your OHSD is started, that's a very much depend upon your OLR. And if you don't have your OLR is missing, and you have to restore your OLR with any one of the valid backup here. Once your OHSD process started, and then internally it's gonna start two agent, Vara root agent and Vara agent. Along with that, you're gonna start your CSSD agent and CSSD monitor. So these two services will get started in your level 1. The moment you do CRCTL start CRS, the very first service is OHS, that HAS service will get started. And that OHST service is internally responsible for starting your 4 services, your CSSD agent, CSSD monitor, and your VARA root agent and VARA agent. So if I go back here, your OHT for services with the first service will get started, and that internally starts your VARA root agent and VARA agent. These are the 2 daemons or 2 services will get started once you start your CRS or cluster. Along with that, your CSSD monitor and CSSD agent will be get started. Your where is that CSSD monitor will be get started, and once the CSSD agent is started, that will be done. Internally, these VARA root agent and VARA agent will start further more services in your Clusterware. It will be your level 2 startup sequence. Once it will move to level 2, this CSSD agent will start your CSSD service. That CSSD service is here. CSSD service will get started. Right, so that will be here. CSSD VARA.CSSD service will get started with help of this CSSD agent. And then this VARA root agent internally will start your furthermore services, your CRSD, your CTSSD, Diskmon, and SFS driver. So your CRSD, CTSSD, and your Diskmon is here. Where is that? CTSSD, Diskmon, and SFS driver. What else? One more thing. Your CRSD. These CRSD, and then CTSSD, Diskmon, and your SFS. These 4 services, along with the CRSD, will get started in this run level 2 with the help of your VARA root agent. That's a daemon. VARA root agent is here, right? This is your VARA root agent. That's going to start all these services. And this VARA agent, this is your VARA agent daemon. This particular daemon will start these services. Your ASM, your GIPCD, your ASM, your GIPCD and GPNPD, the GIPCD, GPNPD, UEMD, and MDNSD and UEMD. So that will be started with the help of this VARA agent, right? And then your CRST, that is a very important services. That's a cluster synchronization, cluster ready service, right? That's a very important service that internally span 2 more agents or the daemons at your level 3. So again, that VARA agent and VARA root agent, these 2 daemons will be get started. These 2 agents will be get started. Those will be here. VARA agent and VARA root agent. These 2 agent is started with the help of your CRST. And then these 2 agents internally responsible for starting all your cluster services, all the cluster resources, your GNS, your SFS registry, your scan, your GNS, node IP, node VIP network, your ASM instance, ONS, EONS, GSD, listeners, services, and databases. All those will get started with help of these 2 agents, which are started with help of your CRSD, right? So that's your entire cluster resources. These are like, 4 levels where your cluster services will get started, right? Any questions on this slide, guys?
Yes, sir. Sir, why we have Aura root agent twice? Why Oracle has given the name of Aura root agent? Is there any specific reason they are in this order? And if you can do a mapping between the actual process ID.
This VARA root agent is basically started with your root user. VARA agent is basically started with your grid user. So the name itself indicates, right? Root indicates those services which are started with your root user. And if you don't have that root, VARA agent, these services are started with your as a grid user, the grid owner, either Oracle or grid. Because like your cluster services, you have to start with the root user. You cannot start using your grid user. That's a mandatory dependency.
And also, sir, Aura root agent and Aura agent have a two services.
Right. So one set of services are started with your OHSD. That's your local OLR by reading your OLR, your local registry. Your HAS service will start 2 agents, and then the 2 more VORA agent and VORA root agent will be spanned by your CRSD. And because your CRSD is the one which is going to responsible for starting your all the cluster resources, the actual resources. These are the daemons. The daemons are spinned by your OHSD with the help of this VORA agent and VORA root agent. These are the daemons it will get started. And your CRSD is the one which is going to start your actual cluster resources at the level 4.
And what is that GIP-CD and GNB-CD, sir? What is that?
You have a different level. We'll talk on that, why we need GPNPD, GIP-CD, and your grid plug and play daemon, and then we have a GPNP profile. Why we need this GIP-CD, we'll talk on that further. Right now, it's at your cluster level service. Just keep it that.
Okay.
Yeah, we need why we need and what time, what's the dependency on my GPNP profile. What's the use of my GIP-CD and GPNP? Once we start our course, actual course,
Okay.
we'll talk deep dive on that.
Sir, can you just go to the server and run the PSCF grep d.win?
It's here.
Yeah, it's already there. Okay. So see, we have like 2 set of services for Aura agent and Aura root agent.
Right.
So and CRSD, this like below process, these 2 below process is spawned by the CRSD.bin. Let's say the process ID is 8031.
Right.
So this is the parent, right? So we are not seeing the parent process ID of it. We are seeing the parent process ID 1.
I did not get that. Oh, come again.
So my question is like, as you just mentioned there in the document, Aura root agent and Aura agent, these services are owned by the CRSD.
One second. Let me. Okay, yeah, please go ahead.
Okay, so these 2 services are spawned by the CRSD.bin service, right?
Right.
The CRSD daemon. Okay.
Right.
If I see the parent process ID of these 2, it is not showing the CRSD daemon as a parent process ID. It is showing as a 1.
Okay, you're talking about this.
Yes.
Right. So yeah, it is not. We cannot compare my OS process, right? Like if one process is spanned internally child process, it has a linking of your parent IDs, but it's like your cluster level. Before your CRSD has to start your these 2 agents internally, it will start some other services. So we cannot map this parent process ID linked to this one, because if you talk about each of these individual services, there are a lot of dependencies. But if the moment you kill this CRSD services, automatically this agent service will go down. So that's a dependency. You cannot compare at OS level, my parent ID has to link with this particular parent ID. But that's an internal linking, how it's gonna cluster will manage it.
Okay.
Yeah.
So just correct me, sir, if I'm wrong. From this chart, what I understood, first it will start the Oracle high availability daemon, and that Oracle high availability daemon, the 4 processes, that is CSSD agent and Aura root agent and Aura agent, and the final is the CSDD monitor, right?
Right.
And CSD monitor will start the CSDD service, Aura root agent will start this 4 service, CRSD, CT, SSD, DiskMore, and ACF.
Right.
And similarly, Aura agent will start the Oracle ASM, GIP-CD, GNPD, EVMD, and MD-NSD.
Right.
CSD will start this.
Right.
And CRSD has just spin up these 2 processes, Aura root agent and Aura agent. Okay.
Right.
So the CRSD actually responsible for starting the entire cluster with the help of Aura root agent and Aura agent. Aura root agent, they started this scan, node VIP, and like correct network level services. And Aura agent has started all the cluster level services.
Right. Yeah.
Okay. Thank you. Is this the process correct?
Right. This is how it works. But if you understand up to here, sorry for that. Like up to here, sorry. Whatever you're seeing here up to here, you cannot see. These all are like your daemons. Whatever you're seeing is all are daemons. You don't see any services. The moment you go to your database, and the moment you do ps-ef grep smon, you don't see any of these processes. Up to here, whatever you're seeing, it's all daemons. Once your Vara root agent and Vara agent starts, those are the one which is going to start your actual database services, your WIPs, your scans, and all other things. Whatever you're seeing, these all will be like get started at the final stage. But these are like demand. Whatever you explained, it's all correct. It's a
Sir,
4 level.
But what do you mean by daemons, sir?
Daemons means the processes. Whatever you're doing this d.bin, these are the daemons. So only the background processes will get started, but your actual services will, actual cluster services or cluster resources will not be started until this level 4. Like daemon in the sense that the OS level, the services will get started.
That is the base actually. Yeah.
Base services, whatever you're seeing here.
Yeah, once they are active, then we are,
at the end, 4th level, you can see your cluster will get formed and then cluster will be ready to use.
Okay, thank you, sir.
Sir, one question here. Yeah, if you can stay on this slide. Sir, all these boxes, the rectangular and square boxes, does it mean that all of these boxes will have one-to-one process Linux process mapping?
Yes, that's correct. Whatever
So
you are seeing here. No, but these are not the processes, your VIPs, your GPNP. These are at your cluster level services get started. The whatever I talked about, the daemons will have its own process mapping. You can check with the d.bin, ps-ef grep d.bin. These are the daemons. You can see your OS level process mapped. And then these daemons will be up to this 3rd level. Once the 3rd level is done, at the 4th level, whatever you are getting started, it's at your cluster level, at your ASM level, at your grid infrastructure level.
And they can have a process or not, but it depends on the what kind of resource it is.
Right.
Sir, for OHSD, I asked, if you can show me the actual physical process. There I can see something called reboot. Is that OHASD process?
Right. This is a HAS process, and we can call it as a OHSD or HAS or whatever it is. Each node will be having its own HAS service, and it will be a OS process, and this is a service. And why it is having a keyword reboot? Because it's a HAS, Oracle High Availability Service. Means the moment somebody kill this process or your HAS goes down, automatically it will restart. That's the meaning of your reboot. So if I do here ps-ef grep again d.bin, this is my HAS, and if I do kill -9, and then my automatically your HAS will get started. ps-ef grep d.bin. Your HAS service will get started. So that's an indication of reboot. Like, nobody can bounce or nobody can shut down my cluster. The moment cluster goes down also, your OHSD service will automatically restarted. That's where no high availability services. Why high availability services? Due to some network issue, all your demands will go down. All the services will go down.
Can you just scroll up a bit? Scroll up.
Yeah.
Earlier it was showing reboot and now it is showing restart.
Yeah, automatically restarts.
Okay, now just run it again. ps-ef grep d.bin.
Restart. It's restarted automatically. The moment you shut down your cluster and start it, it will be in a reboot mode.
So it is like a restarting of a node, like?
Not a node. It's only that particular service.
So on that node, sir, there were other services like database instance was running.
Right.
Will that database instance crashed or?
No, it depends. For example, right? This is OHSD service, right? Your database will not crash, and all the services, everything will be keep on running and up and running, no impact at all. But if you talk about this CRSD, right? I'll just see this one. Kill -9 CRSD. Done. So if you do d.bin,
this will crash everything, I think.
Right. No, not yet. Your CRSD will come. Not an individual node level I'm talking about. d.bin, your CRSD is back online with the reboot. Which service I can kill? Most of the service, if you kill, automatically it gets your OHSD service is responsible for restarting all of them. But what I can show you here, I can do this one.
So
One service, if you one service, if you kill it, automatically it will get start. Like, let's see, I can do multiple services kill. You can see the difference.
So, sir, when you killed OHSD, nothing happened to the database instance.
Right.
You killed CRS, nothing happened to the database instance, right?
Right. So
But
now, yeah, now I kill multiple process, gone, my server gone now.
Okay.
Gone in the sense, because one or two services if you kill, automatically it will recover it instantaneously, because your cluster will never go down with one or two services. If the multiple services will killed be due to your network issue or something else, then you may see that cluster reboot or your node reboot, right? Your cluster went down. Because like multiple services are went down. And then once you start your cluster, it'll automatically start your all the cluster services. Why it'll automatically start? Because of your OHSD. That's a first init demand which will get started, and it will be part of your OS init D process. Init D process means if the moment you start your Linux box, the init services are one which will get started, and it's part of your init demand, init D process. Your OHSD process will be automatically get started, and if the init your OHSD is get started means internally it's going to bring up all your services.
Okay, that's the reason the parent process ID is one for each and everything.
Right. Not one for that. That's not the reason. Your OHSD is the one which is going to be responsible for starting your all other services.
So, well, like when we just run the CRS-CTL start CRS, so Oracle high availability service is the first process which start, right? Which is start first. This
right.
is the, and this is start all the processes.
It internally starts all the services. That's a startup sequence, right? Your HAS will start. That's a dependency about your all the cluster services.
Okay. If we do the CRS-CTL stop CRS, then what would be the sequence?
Same thing, right? It's going to shut down your all the cluster services, and it's going to shut down your HAS.
HAS in the last.
Right.
Okay.
The moment you stop your HAS, automatically it will shut down all the cluster, and then it will not stop. Because the moment you kill this service, this is a baseline service for all the demands and all the services, right? The moment you stop this one, automatically will stop everything here. Okay. The moment you do CRS-CTL stop HAS, gone. Like, all the services will be killed here.
Right. Sir, what about this CSSD agent and CSSD monitor?
Those are your agent services responsible for spanning remaining services.
No. Cluster synchronization service daemon I'm talking about.
Cluster synchronization service daemon.
CSSD. Top.
CSSD. Oh, this is your synchronization, right? We talked about that locking.
Networking and disping, yeah?
No, this is the different thing. Like, we talk about that. Your node eviction, node goes down, everything will be like managed by your CSSD, cluster synchronization service daemon. Your node eviction, if the node 1 is not able to ping, node 2 is not able to ping, your CSSD will be responsible for evicting that particular node from your cluster.
Okay. Sir, one thing, see, what Oracle has done it, or the developers of RAC would have done it, they have initiated in level 1 or a root agent. It initiated some processes, and then one of them, CRSD, initiated in level 4 some services. Right. Why did Oracle not, using the Aura root agent in level 1, initiated these also? Because it's just a process. You need a process to initiate it. Why was a need that they made a level 3?
I will tell you one simple thing, right? Like, your OHSD knows only about your local resources. OLR, it's going to read that local. Let's talk about this one here. You have this node 1, you have this node 2. Sorry for that. Where OHSD, OHSD here, and then your OHSD. It's gonna start your Aura agent and Aura root agent on both the nodes. And then your OHSD will start only your OLR, right? Whatever the content of your OLR, the local resource is going to start by reading your VORA agent, whatever your CSST, whatever the CSST monitor, only that local resource will get started on both the nodes. And then internally it will start your root agent, so that, I don't know what are the cluster resources to start on both the nodes. I'm going to start my VORA agent and VORA root agent. That cluster can handle that. And VORA agent internally start my CRSD. And this CRSD is a very, very important process, which is going to read OCR. And then this OCR is nothing but your cluster resources, right? And then this CSSD will internally start VORA root agent and VORA agent, and the CRSD will read your OCR content, and then that CRSD will start all your cluster resources. Because of that dependency, my OHSD cannot read my OCR. So because of that, they came up with one more set of VORA agent. And then again, the question is why VORA root agent and VORA agent? Because some services should be started with the root because of that VORA root agent, and some services will be started with Oracle or grid user. So because of that, this VORA agent.
So in real time, we need that Unix team support for that root, starting the services, stopping the services.
Yeah, most of the time when you're working as a RAC DBA, you will be having a sudo access. Oracle user will be having a sudo access to root when you're working on a RAC.
Okay.
Right. So this is the explanation.
And sir, one more question I have.
Mm-hmm.
So like when we just start the CRS, it will start CRS. OHSD is the first service, right? So right. OHSD read the OLR file first.
Right. So your OHSD service, it's gonna first main thing it's gonna read OLR, and then it'll start it. And when it comes to CRSD, the main thing it's gonna read your OCR and then GPNP profile, and it'll start your cluster services. And your CSST service, it depends upon your voting disk. If you don't have a voting disk and your voting disk are missing, your CSST service will not start. These are dependency. Your OHST depend upon OLR, and your CRST depend upon your OCR, and your CSST depend upon your voting disk, and your GPNP depending on your network, your NS lookup forward resolution and reverse resolution. So these are like dependencies main I just listed out. So these are like commonly asked question. What's the dependency for my OHST? Your answer should be your OLR.
So if OLR is missing, we don't have the backup also, but we can do recovery.
If you don't have a backup, you will not be able to,
OLR.
You will not be able to restore your OLR. You have to reconfigure that node, delete that node and re-add it.
Okay.
Sir, hello.
Yeah.
Sir, one quick question. So in our if we are configuring a basic file system standalone database, right. The name resolution, I don't think it's mandatory, right?
For standalone,
it's not okay. But standalone here it's playing an important role.
Right.
Okay.
Right. So that's it. I think we are almost above the time. Quickly, I can show you one more thing. For all of this, what you can say directly, you can go to your grid home or the Diag Oracle base, and you can get the log. Like, we talked about all these services, right? When you start your cluster services, you're going to do crctl stat resource -t-init, and whichever the service is getting stopped, it is getting stopped at my CSSD monitor. Then I can directly go and I can check my CSSD log. If it is getting stopped at my CRSD log, it will be intermediate and it will be in a starting state. I can directly go to my CRSD log and I can check the particular file. All of these logs will be inside your Oracle base, U01 app, Oracle, Diag, and CRS, and node name, and CRS, and trace. So this is a path for your all the trace files. So if I do ls, and you can see all the trace files here. So in 19C onwards, it will be not a log, like CSSD.trc and gipcd.trc and your ctssd.trc, evmd.trc, and ohsd.trc. In 11G, it will be the .log. In starting with the 12.2, they started with the .trc. So assuming that my OHST process not starting, I can directly go here, and assuming that my CRSD process not starting, I can directly go inside that. I can look for that why it is not starting, what's it not starting, and then by looking at this log, we can troubleshoot why it is not starting and what's the issue and all those things. Right. So this is your log location. You can get it out here. Other way, simplest way to find it out, like, you have to go to your Oracle base and your diag, CRS, node name, CRS, and then the trace. Other simplest way is to, like, CRS CTL stat resource -t -init, CRS CTL stat resource -t -init. Okay, I have not set the environment, plus ASM1. Assuming that my CRSD is not starting, it will be in an intermediate state and it will be in a starting state. So I can directly do this locate command, locate, and I know that it will be ending with the .trc, CRSD.trc. So immediately the moment I do locate command, I'm going to get that path. I can directly go there, and then I can get all the logs, like, your Oracle base, and your CRS, node name, CRS, and then the trace. So you can do this locate command and then start, like, your GIPCD is not starting. It will be like intermediate and it will be in a starting state. You can quickly locate GIPCD.trc, and then you're going to get that path. So you can go inside that, you can tail that log, and you'll find it out what is the reason why it is not starting. All the logs will be on the same location on this particular path. All the logs ending with .trc. That's your troubleshooting logs, guys. All right, that's
we have one
much.
alert log file at cluster level, no, sir?
Your ASM also has its alert log, and your
at
each
CRS
node,
level, CRS level.
Yeah, your node also has its own node 1 alert log, node 2 alert log. That's your cluster level alert log.
So
And
this is the consolidation of all, right?
Consolidation of all in the sense?
Consolidation of all logs.
No. That's only specific to that particular node. If there's an issue with that particular node, you're going to check that log. If I share my screen again here, like, you have all the resources.
I know that that is for that particular node, but it shows the information for like CRSD, CSSD, all.
No.
All the process.
No, you don't see much information on this alert. Like, if your cluster is rebooted or your node evicted due to some node issue or any other issue, you can good way to check your data, this particular node alert log, but it will not give you more information. You have to go for a particular processes or the daemon which is not starting or which is causing, and check for that particular reason why it is not starting. It will be having very less information of this particular node alert.log.
So in case something goes wrong, first it reported here, alert.log.
Alert.log, yeah. It's a good to check if the node is evicted. First thing to check is your alert.log and your CRSD.log. Your CRSD is the one, your CSSD log is the one. You're going to check the CSSD log and your alert.log. These are the two logs. You're going to first basically check when the node is evicted, and you're going to get it out why it is evicted, and then go to that respective daemon in that particular CSSD log or in that particular alert log. You're going to talk about, okay, my network is causing that issue, or my GPNP profile is causing issue. Then I can go to my GPNP profile and then check for that particular more detailed error. But when you're starting or when you're patching, when you're bringing down or bringing up, if that particular service is not starting, then you can go ahead and check for that respective services. If it is storage is not starting, you can go ahead and check your storage agent here. And if your OHSD is not starting, you can go ahead and check your OHSD. And if your CTSSD is not starting, you can go ahead and check your CTSSD daemon services. And that's going to give you a particular root cause why it is not starting.
Okay, thank you.
All right, guys. So we are almost about 13 minutes of scheduled time. So anybody has any questions before we wind up this session for today?
Sir, I have one basic question. Yeah. So if I have a cloud access, cloud subscription, can I run your whatever ready VMs for the rack?
No,
it's not possible. Right? Okay.
No.
So I have to every time I have to manually configure the system over there.
Right. You have to configure, and you have to, once you use it, you have to shut it down after that subscription, right?
Yeah.
All right. So anybody has any queries, questions regarding our course and content, or any particular topic need to be included, or whatever the feedback, you are welcome to
Sir,
mention your comments.
is it possible to add a rack performance tuning in the syllabus?
I need to think through that, because that's not an easy topic, because that's going to take a lot of time and effort. That should be a different story.
Okay, and second, like the rack troubleshooting would be there, right? If
rack related, everything will be there here. Rack related, it will be too much. You can see this in this course. Each and everything will be discussed here, especially with the rack troubleshooting.
This topic we are covering patching and upgrades also, sir.
I think if I heard you correctly, you're talking about the patching, right?
Yes, patching.
Right. Yeah. Patching will be covered. Your ASM cluster level patching, rolling patching, non-rolling patching, your database patching, and your data patch. Yeah, your cluster upgrade, your database upgrade, everything will be covered here.
Okay.
All right, guys.
Sir, will you share the interview question now?
Yeah, each and every topic also we'll discuss about the questions and answers, and also I'll uploaded some of the commonly asked questions and answers in the drive itself already.
Okay, thank you, sir.
All right. Any last questions, queries, guys? Otherwise, we're good to wrap it up. All right, guys. I'll take it as a no. We'll see you in our regular classes, guys. Thank you.
Thank you, sir.
Thank you, sir.